Hello, everybody. This is our first video about arithmetic and geometric sequences. I thought I would start by doing there's a couple of just little random pages here, random problems here on the first page about just sums and sigma notation. I thought I would do these problems just as a little review for us. So you can see the first one, I kind of wanted to point out that it says write out the following sum. And what that means is I want you to like write each term, add it up. It's like a way for me to know that you guys know what the sigma notation actually means. So if I said write out the following sum and this was a problem, you would want to write out something like 3 plus 1 over 3, starting at 3, going to 7, plus 4 plus 1 over 4, plus 5 plus 1 over 5. Yeah, that's right. Plus 6 plus 1 over 6, plus 7 plus 1 over 7. And then you stop. So it's like 4 thirds plus 5 fourths plus 6 fifths plus 7 sixths plus 8 sevenths. You don't have to add this up because it says write out the sum. It doesn't say evaluate or something. So you can just leave it like this, or you could write 4 thirds and 5 fourths and 6 fifths if you want to, but this is fine. And these next two say write each of the following series in sigma notation. So this, you have to like actually come up with your own little expression for what each of these terms looks like. And it looks, I always start at I equals 1. Got 1, 2, 3, 4, 5, 6 terms. So I'll put a 6 up here. I'm going to try and figure out what this is. And maybe you recognize that these are all perfect squares down here. Really, you could write a 1 under this. And then it's like 1 over 1 squared minus 1 over 2 squared plus 1 over 3 squared. I'm going to need a -1 to a power to get the right signs, because you can see that the signs alternate. That means this term has to exist. And then there's going to be an exponent here. So the first term is positive, which means I want -1 to be squared. If -1 was raised to the first power, then this first term would be negative. So I'm going to call that I plus 1. Because now when I is 1, this is -1 squared, which is +1, and the first term is positive. And then times whatever the term is, and it looks like it's 1 over I squared. So this is your sigma notation for this, -1 to the I plus 1 times 1 over I squared. And then this one looks like, again, it's alternating, and it starts with a positive. So I'm going to have this same term here, I plus 1. And then I got to figure out how to write this, 7, 10, 13, 16. So it looks like the common difference, the difference between each one of these is 3. Maybe I'll call that D just for fun. And then how many terms are there? I mean, you could just count them. 1, 2, 3, 4. 19 would be 5, 22 would be 6, 25 would be 7, 28 would be 8, and 31 would be 9. So it goes up to 9. Could also do this. 31 minus 7 divided by 3 is 24 divided by 3, which is 8. And this is a little confusing because you're like, well, this says 8 and that says 9, but what this 8 means is that you add the number 3 8 times, but that means that there's going to be 9 terms. Because the first term and the last term, you miss one of those when you see just this 8. And then you got to write an expression for the term. Since the common difference is 3, that tells me I should have a 3n in there. And then I just got to get to 7 from there. When n is 1, 3n is 3. To get to 7 from 3, I have to add 4. And then you check. 3 times 1 plus 4 is 7. That works the first term. 3 times 2 is 6 plus 4 is 10. 3 times 3 is 9 plus 4 is 13. That seems to work. So then I do 3n plus 4, and I'm good to go. So that is our little review of how to write series in sigma notation and how to evaluate sigma notation. This is today's topic, arithmetic and geometric sequences and series. They're just the two most common kinds of sequences and series are arithmetic and geometric, and we have some formulas for them. These definitions, and we have formulas for finding the nth term and formulas for finding sums of these things, depending on what the question is asking for. So we're going to see what those are. The next two slides are going to be really important ones for your reference moving forward. So an arithmetic sequence is a sequence or series with a common difference between terms. What that means is that there's like the same, like you add or subtract the same number to get from one term to the next. So an example of this, I don't know why I'm writing a sigma, just kind of, I'm in that kind of headspace now apparently. I don't know, like 2, 4, 6, 8, 10, 12. So that looks like these are just the even numbers, you're just adding them all up. So for a sequence like this, I would say the common difference is 2, and the first term is 2 also, happens to be 2. And the formula, there's a formula for writing the nth term, nth. Let me start that over because that's a real mess. The nth term of an arithmetic sequence the explicit formula is an equals a1 plus n minus 1 times d. So the nth term is the first term plus n minus 1 times the common difference. So this d and this a1, this d and this a1. So like for this sequence, the nth term would be 2 plus n minus 1 times 2. And this is 2, and 2 times n is 2n, and 2 times negative 1 is minus 2. So this actually just ends up being 2n because those cancel out. So the nth term is just 2n. So if I said, like, find the 300th term of this sequence, you would say A300 is 2 times 300, which is 600. This one's not that hard because these are just even numbers and you might know what they are, but if it was a different sequence, like, let's look at maybe I could want to use that one from before, maybe 3, 7, 11, 15, 19, This is like you keep adding 4 each time. So now I'd say D is 4 and A1 is 3. And now the 192nd term, well, sorry, you got to write the nth term first. So for this, I would say the nth term is A1, which is 3, plus n minus 1 times the difference, which is 4. So this is 3 plus 4n minus 4, which is 4n minus 1. And we did this before just by like kind of guessing and checking. Like we did this in the example, in the warm-up problem before by saying since the difference is 4, I want there to be 4n. And then I just adjust that so that it matches the first term. And now I have this formula, so I don't have to worry about guessing and checking. So now I can say A192 is 4 times 192 minus 1. And 4 times 192 is 768. So this is 700. So the 192nd term of the sequence will be 767. This is much faster than just having to like actually go 192 terms up. That's how we find the nth term. That's what an arithmetic sequence is, a sequence with a common difference. And the nth term of these things looks like this. Okay. Next, we will say define what a geometric sequence is. So it's similar, except now this is a sequence with we call it a common ratio between terms. And what that means is that this says ration. That's not right. Ratio. What that means is that instead of adding or subtracting something to get from one term to the next, you're going to multiply or divide something to get from one term to the next. I think of it all as multiplication. Like you just keep, if you divide by 3, I think of that as multiplying by a third or something. So an example of such a sequence or series, oh, I guess I'll do a sequence, maybe like 1, 3, 9, 27, 81, 243, da, da, da. So here I would say, as before, you want to identify the first term as 1. And now the common ratio we're going to call R. Looks like it's 3, because to get from here to here, you multiply by 3. Maybe I could have one like 64, 32, 16, 8, 4, 2, da, 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 whatever. So now my first term is 64. And my common ratio now, I would say, is 1/2. And that's just like basically, what do you multiply by to get from this term to this one and this one to this one? You multiply by 1/2. One way to find the ratio is to just divide a term by the one before it. You notice here that 3 over 1 is 3. If I divide the second term by the first one, I get 3. If I divide 9 by 3, that's the third one by the second one. If I divide 9 by 3, I also get 3. If I divide like 243 by 81, I get 3. Basically, anytime you divide any two terms, you're going to get 3. And the same thing works here. 32 over 64 is 1/2. 16 over 32 is 1/2. 8 over 16 is 1/2, and so on and so forth. And the nth term formula for a geometric sequence is the first term times the ratio to the n minus first. So this is like the formula we saw on the previous page. This is the formula for the nth term of the geometric sequence. I could write that for these, like maybe for this one, the first example. You could say AN is A1, which in this case was 1, times the ratio 3 to the n minus 1, which is really just 3 to the n minus 1. Because 1 times anything is just the thing itself. And similarly down here, A sub n is 64 times 1/2 to the n minus 1. Let me emphasize this as much as I possibly can. This does not equal 32 to the n minus 1. Like, it's tempting to be like, well, 64 times 1/2 is 32, but that doesn't work because this is raised to a power and this is not, so you cannot multiply these numbers. Let me say that again. You cannot multiply these numbers because one is raised to a power and one is not. So this is wrong. No, don't do that. That is incorrect, okay? I could get rid of this 1 because 1 times anything is just the thing. But I didn't multiply 1 by 3, I multiplied 1 by this whole expression. The 64 is multiplied by all of this stuff. Don't forget PEMDAS. I got to do the exponent before I do the multiplying. So I got to somehow do this exponent first, so I cannot multiply these and leave that exponent there. So definitions of arithmetic and geometric sequences. I'm going to stop here and I'll do some examples, and then I'll do another video about sums. So keep an eye out for those.